Today we're going to wrap up our discussion about absolute value. Two final things we're going to look at. One is finding intercepts, and the other is domain and range. And then we'll just practice these as we go through the week. So let's talk about how to find intercepts with an absolute value function. So we remember back to when we were looking at linear functions, and we said we could find intercepts of linear functions by letting x be 0, plugging it into the equation, solving for y, letting y be 0, plugging into the equation, solving for x. Same exact thing happens here with an absolute value function. I know this should look like a V shape, and I also know from our work yesterday that the vertex of this function should be at 3, 1. So I'm going to go to that vertex. 3, 1 is right there, and I'm going to put a point. I know this one is opening up, and I could do this a lot of different ways, but what I want to focus on is finding the intercepts of this function. So let's see. If I want to find the y-intercept, the point where it crosses the y-axis, I'm going to substitute 0 in for x. Y equals absolute value of 0 minus 3 plus 1, and I'll solve for y. Y will equal 0 minus 3 is negative 3 plus 1. The absolute value of negative 3 is 3 plus 1, which gives me a y-intercept of 4. So when x is 0, y is 4, which puts my y-intercept right there. The question is, does this have any x-intercepts? And it's possible that it doesn't. In fact, I'm going to go ahead and make a guess that this does not have any y-intercepts because I know this is the vertex and I know it's opening up. That means I shouldn't have any y-intercepts. Let's check out and see, though, what happens algebraically, or what that means algebraically to this function. So again, to find the y-intercepts, I'm going to let x-intercepts, I'm going to let y be 0 and solve for x. 0 equals the absolute value of x minus 3 plus 1. And now, hey, this is one of those absolute value equations that we've been solving all year. So I'm going to isolate the absolute value by subtracting the 1 from both sides. That would give me absolute value of x minus 3 equals negative 1. And at this point, if I remember, the absolute value cannot equal a negative. That would mean this equation has no solutions, which is why there are no x-intercepts. That tells me another clue that there are no x-intercepts for this function. Remember, I could go ahead and break this down into the two cases. X minus 3 equals negative 1, x minus 3 equals 1, and I could solve. I would get x equals 2 and x equals 4. But if I check those two numbers in the absolute value equation, if I put in a 4 here, 4 minus 3 is 1, but its absolute value is not negative 1. There are no solutions to this equation, so that means there are no x-intercepts. I do know that y equals 4 is kind of a mirror point, so there should be another point on the other side, and I can draw my absolute value like that. Let's try one more where there are x-intercepts. Okay, so our new function y equals negative absolute value of x plus 3 plus 4. And again, looking at the ways we can find the vertex, I would know it is at the opposite of positive 3, so negative 3 comma positive 4. So my vertex here should be up here at negative 3, 4. And then because of that negative 2, I know it's opening down, so it's going to go something like this. And there should be y-intercepts here. So we're going to go through that same method, plugging in zeros and finding our intercepts. And if I plug in 0 for x, I get y equals negative 2 times the absolute value of 0 plus 3 plus 4. That's negative 2 times 3 is negative 6 plus 4 would be negative 2. So when x is 0, y is negative 2. That's right here. And again, I should have kind of a mirror image point on the other side. 1, 2, 3 units away, 1, 2, 3 units away. There should be another point here. But what I'm looking for next is the x-intercepts of this function. So I'm going to, again, go through and do the algebra to find out where they are exactly. So if I plug in 0 for y, I have 0 equals negative 2 absolute value of x plus 3 plus 4. And I want to isolate that absolute value by subtracting the 4 from both sides. So negative 2 absolute value of x plus 3 equals negative 4, and then I'm going to divide by the negative 2, which will now turn that right-hand side into a positive. So I have divide by negative 2. I get x plus 3, the absolute value of, is equal to a positive 2 now. Now I can set up my two cases. I'll do that up at the top of the screen to save some room here. My two cases would be x plus 3 equals 2 and x plus 3 equals negative 2. Subtracting the 3 from both sides would give me x equals negative 1 and x equals negative 5. Well, that means those are my x-intercepts. It's where it crosses the x-axis. There's two of them here, negative 1, 0, and negative 5, 0. That should make sense with the rest of our graph. Let's see, negative 1, 0 is right here, and negative 5, 0 is right here. And now I have a beautiful picture of my absolute value function. That's it. So plug in zeros for x's, plug in zeros for y's, but play smart. Sometimes there aren't any x-intercepts, and that's okay. There should always be a y-intercept. Try these next few problems.